All right, so if anybody's watching this and it's like 6:35, it's almost like we're hanging out in person right now. So let's keep doing physics because that's what I know you guys enjoy. Let's see here. Question 7. A 50 kilogram student threw a zero point 0.4 kilogram ball with a speed of 20 meters per second. What was the magnitude of the impulse that the student exerted on the ball? So the ball was thrown. So at the start, the ball had zero velocity, which means it had zero momentum. We went over this today, that impulse is equal to force times time, but impulse is also equal to the change in momentum. And we can find that by saying mvf minus mvi. Now in this case, since the ball was thrown, it probably started with zero velocity, so this piece is like subtracting zero. So we just need to find this piece. What was the momentum at the end? It was 0.4 kilogram ball, and it was 20 meters per second. So the answer is going to be 8.0 Newton seconds. And that is the change in momentum, which is also equal to the impulse. 8. In the diagram below, a 60 kilogram roller skater exerts a 10 Newton force on a 30 kilogram roller skater for 0.2 seconds. What is the magnitude of the impulse applied to the 30 kilogram skater? So, same equation as before. Impulse is equal to force times time, which equals mvf minus mvi. All right, in this case, we're looking for the magnitude of the impulse. We have a 10 Newton force, so the force was 10 newtons. The time was 0.2 seconds. All right, we're looking at the 30 kilogram roller skater, so the 30 kilogram roller skater, well, actually, we have enough information right here to solve this. All right, you just want the impulse. Well, impulse is force times time, so impulse equals ft, which is just 10 times 0.2. So 10 times 0.2 is 2. So 2 Newton seconds. So that's the impulse right there. All that extra information was kind of just there to, I guess, confuse you, make you decipher what's important, what's not. So let's see 9. A 40 kilogram mass is moving across a horizontal surface at 5 meters per second. What is the magnitude of the net force required to bring it to a stop in 8 seconds? So in this question, it again is going to be dealing with impulse. So force times time equals mvf minus mvi. Now in this case, they want to bring the object to rest. So the final velocity is going to be 0. So the final momentum will be 0. So let's look at what the initial momentum was. 40 kilograms is moving 5 meters per second. And we're looking for the force, and they've been giving us the time, which is 8. So we have 8F equals, what's that, negative 200. Divide each side by 8. I'm going to get that F is equal to about 25. So in this case, it's negative 25, but the direction doesn't matter. The negative sign only matters if we're talking about the direction. So 25 newtons is good enough. So let's look at question 10. A 1.5 kilogram cart is accelerated uniformly from rest to a speed of 2 meters per second in a half second. What's the magnitude of the force producing this acceleration? So again, they're looking for force. All right. And we have mass, final velocity minus mass times the initial velocity. In this case, the cart was starting at rest, so the initial velocity was 0. It's a 1.5 kilogram cart, and you want to bring it to a speed of 2 meters per second. You're looking for the force, and it's happening over a half second. So 2 times a half is 3. 0.5 F, divide each side by a half. 3 divided by a half is going to be 6. Question 11. A 1,200 kilogram cart traveling at 10 meters per second hits a tree and is brought to rest in 0.1 seconds. What's the magnitude of the average force acting on the car to bring it to rest? So same setup. We're looking for the force. We're bringing something that has a velocity to rest. Okay, since we're bringing it to rest, its final velocity is going to be 0. All right, so 0 minus its initial velocity, which is 1,200 times 10 meters per second. And it's coming to rest in 0.1 seconds, and we're looking for the force. So this is going to be 12,000 equals 0.1 F. Divide each side by 0.1. And we're going to get 1.2 times 10 to the 5th. During a collision, an 84 kilogram driver of a car moving at 24 meters per second is brought to rest by an airbag in 1.2 seconds. The force exerted on the driver by the airbag is, all right, same setup, force times time. All right, I'm not going to write the equation out, so let's just look right here. We're looking for the force. It happened in 1.2 seconds. Okay, the guy is being brought to rest, so that means that the final velocity is 0. We just have to look at what his initial velocity was. All right, 84 kilogram driver, and he was traveling 24 meters per second. So we have 1.2 F equals 2016. Divide that by 1.2. We're getting 1680. And that's going to be close to choice 3, which is 1.7 times 10 to the 3rd. All right, because they said approximately here, so we can have a little bit of error. All right, what are we on? 13. A 0.1 kilogram rocket engine is designed to deliver an impulse of 6 Newton seconds. If the rocket burns for 0.75 seconds, what's the average force? So impulse equals force times time. That's all we're going to need for this one. They're telling us that the impulse is 6. We're looking for the force, and they're telling us that it's happening 0.75 seconds. So this is just going to be 6 divided by 3/4, which is 8. 14. A mother pushes a 120 Newton child who's sitting on a swing. If the mother exerts 10 Newton force for 0.5 seconds, what's the magnitude of the impulse imparted to the child by the mother? So once again, they're looking for impulse, and we're talking about force and time. So the mass of the kid isn't necessary. So they want to find impulse. They've given us the force, which is 10 newtons. They've given us the time, which is a half second. So impulse is just going to be equal to 5. What am I saying? 5 Newton seconds.